So again, this is a nice separate one-off kind of topic. My hope and effectively my requirement for your reports that you submit for this is that we will use LaTeX for it. It can sound and look a little intimidating at first because it's a little bit more of a programming or layout feel than it is just a document editing feel. But with the web-based application we use and with the starter template we use, there are still a couple of headaches that you have to overcome, but the end result will be a document that looks exactly right. And that's a nice place to be as well. You don't have to worry about, are my margins correct? Is my font correct? Am I spacing things correct? That's the part that gets all taken care of for you when we use this. So we deal with a little bit of the learning curve to get a new tool in our toolbox. Um, in my opinion, once you gain that just enough experience that you can go into Overleaf and work on projects, you'll start switching to it for other things as well. Whether it's worth it for a homework assignment in a class or not really depends on what kind of grade or time you want to put in. But I think there's no denying that the end result looks better. Um, so this is a brief outline. This is just an introduction. What is LaTeX and why, and then using Overleaf as a class. I suggested that if you have a laptop or device, feel free to bring it out for this. It's not a requirement. I'll be providing a couple links, and we'll just do a couple exercises, brief ones together, just for those of you who haven't done it to get your first kind of experience with it. So when I say, why do we use LaTeX? This is meant to be an illustrative example here. This is a version of basically the syntax of what LaTeX can look like. And then this is the corresponding sort of layout of what the resulting PDF you get generated. So for all of these papers that you're reading and categorizing and building your survey tree, it really does depend on the sub-discipline, but certainly if it's computing related, computer science, computer security, anything AI, machine learning driven, it's almost a certainty that they're using LaTeX. In double E, it's a bit more of a mixed bag because you can make a document that looks like this using other software, including Microsoft Word, and there's templates that can give you this end result. So it's maybe closer to like a 50-50 there in terms of whether researchers in the field use LaTeX or whether they use Microsoft Word or Adobe or other documents to create their documents um, with other document editing software. It's certainly computer science, computer engineering, it's pretty much ubiquitous. So as we're doing graduate level work in this department, it's a good thing to claim to be able to do. And I think the end result is you're working with a little bit of extra syntax. It's not as easy as just typing in your name into a document. You need to now create an author block. But then the end result is something that looks pretty professional, and that the hard problems of how do I lay out a document properly with a template in place are already pretty much solved for you. And we can talk more about ideas and about how to phrase certain things and how to visualize certain data versus worrying about how we do a line break and how we do these kind of things. All that gets basically solved for you once you eventually get enough experience with the software and related services we have here. So first, just a brief note about pronunciation. LaTeX, call it latex, it's fine, it doesn't matter. It is something of an evolution of the original tech software and algorithms for layout, which were created by really one of the godfathers of computer science, Donald Knuth. Um, it is a document preparation and markup language. So when we see that, you can start to think about things like HTML as another type of markup language, or Markdown is another kind of markup language. We are writing primarily with the text that we want, and then we have these additional markups we're adding to the document to get certain features to appear a certain way. So in Microsoft Word, if I wanted to do this, I would click the GUI and click italics, and then unclick italics when I was done, because if I forget to, the next word is also in italics. Likewise for doing bold. There's keyboard shortcuts. People can be very efficient in doing it. When instead we're in LaTeX, when we're in a typical text editor, we are instead using these basically commands or markups to say, this is going to be emphasized, which will typically look italicized. This is text that's going to be bolded. That part's going to be bolded there. It's pretty commonly used. Certainly for math-heavy papers, it's extremely prevalent. For things that are covering algorithms and heuristics for solving problems, it's extremely prevalent. What there is a very loyal and wide public following associated with people who are trying to extend it, make it better. we don't always get to this point when we're working on our projects, but it's really nice to be in a place eventually with regards to a research project in which you have some code and you want it to run overnight. And so you hit it and you go to bed. And if you wrote that code properly, the end result is maybe some data that gets generated. And then we have some other code we then write that takes that data and it formulates it in a really nice looking graph or figure of some sort. We can now, using LaTeX, also take that result and automatically regenerate the final PDF of what we want that paper to look like. Versus the other world in which, okay, I've run the code, I now need to export this image manually and then copy paste it into the figure and make sure it doesn't move things around properly. In theory, we can get to a place, and again, we don't always get there with our timelines, where we hit build paper and it takes all the new data, takes all the new results, generates the new paper based on your writing about that data and that results. And it's a really nice uh, place to be because you can really worry about ideas and code and fixing a bug in your software that leads to a different looking result and not having to do this kind of manual labor intensive process because it is really, once you get to a good place, it's hit a button, generate new version of the paper. Does require a little bit of a shift in thinking. Microsoft Word or Google Docs are examples of what they call a WYSIWYG editor. What you see is what you get, meaning what you are seeing is what the actual document is. If I want large font, if I want this word to be in 40-point font, I go in, I change the font size of that word, I then see it immediately in the document as I'm editing to be 40-point. LaTeX has some WYSIWYG style features, but for the most part, it's what you see is what you mean. It's a lot closer to encoding via this language, separate language, what you want it to look like, and then running software to take that as a specification and generate what you want. In theory, part of the beauty of it, and your mileage may vary depending on how comfortable you get with it, is you can focus on the content of the document and not the appearance of the document. When I'm working in Microsoft Word, and if I really want something to look properly, I'm constantly fidgeting. I'm constantly trying to get this paragraph to look right and to get the justification of the paragraph to make sure the margin looks exactly like this, and then accidentally the figure gets moved on to the next page. Um, in theory, at least once you get into a comfortable spot with it, you can describe what the content needs to be. You focus on just the plain text of what you want to say, and then you don't have to worry at all about what it's going to ultimately look like, the actual appearance of it separately. That does require that separate step. You encode what you want, the content, then you do run this piece of software that's basically like a software program, basically compiling it and saying, here is the end result. The end result's not a software binary anymore, it's basically a PDF, but it follows a similar kind of thought process of encoding what we need versus just directly formatting the content of what we want. So one step can be to go through and install LaTeX directly, then install a IDE for it, like you would be when potentially starting with any other piece of like new programming environment, new language. You can still do that. There's TechMaker, TechStudio, TechWorks. There's a bunch of other competing IDEs. A lot of them are all open source and free. They're all perfectly fine. I have this here in the slide to consider doing this, but I have at least personally 100% switched over to Overleaf. A couple years ago, I would not have said that. Overleaf has a couple downsides as well, but it's just too convenient for me that it's just hard to ignore how convenient it is to be able to manage these documents. To the extent that if Overleaf went away tomorrow, I'd have to really recalibrate some of my own workflows. If you use your iastate.edu email address, you get an account that has some reasonably professional features associated with it. If you haven't done it yet, today, it'll be a requirement for your Creative Component reports. And for those watching this video, use your iastate.edu email and create an account on Overleaf. This is what Overleaf looks like with the code, source code on the left, the resulting PDF on the rightmost tab. And what's not quite shown here, this is a slightly older version of the software that I took a screenshot of. And really, I adapted these slides from the slides that the library provided, so thank you for that resource. So it's not even stuff I created. There's basically a build button. Any of those arrows are effectively a build. Go from this, build it, like compiling an application, generate that resulting PDF. There is also a so-called rich text editor, which is an attempt to give you more of a Microsoft Word or Google Docs style interface, but it sort of, in my opinion, defeats the purpose. And I want you to stay within the source code view so that I can directly see what you're doing here, and we can make changes as need be. So those of you who have your laptops with you, let's go to that link if you can, and I can open it up directly here as well. And this is just a link to Overleaf and just kind of an example document of how to get started with Overleaf. So I'll give you a moment to, if you want to, you can always do this offline separately. This is kind of the starter Hello World LaTeX document in Overleaf, which I also have open here. Let's go back to the link real quick. That's bit.ly isu-latex-hello. And if you don't have a device and just don't want to do it right now, that's fine. You may have to create your account, and it may take you a few more steps. And you can do it offline. That's fine. And these slides are on Canvas, if you recall, if you want to go directly click the link there. So here is an example of effectively sort of the simplest LaTeX document one can create. So you have your comment block, which how much we need to comment our LaTeX code is kind of up to you. Like when you're writing a program, you may choose to add lots of comments so that you can remember why you did things certain ways. What's more common with our quote unquote comments in LaTeX is if instead we want to just block out some text that we wrote. Like we wrote some shorthand text and it's a placeholder, and then later on, I actually only wanted the word hello. I didn't actually want the word world in that sentence, and I just commented out. It's less common we add comments for like understanding of source code because there isn't that much to understand here. There's not going to be for loops and recursive function calls and things and data structures and things of that nature. It's really just formatting and syntax. See if I can make this a little bit bigger so you can see it on the screen in front of us here. And I could break down what all this means, but I really don't need to. You're going to have a document class that defines what type of document and or template you are using. This is kind of a default blank one. Everything we have is going to fall within a begin document and end document, kind of like HTML tags. If you've had any experience looking at that, it's not really that different at all. And then you just have your raw content here, and you have your hello world. What is different is, like I mentioned, now Overleaf, this is already opened up. You have your sort of source code view here on the left, and you have your PDF view, and this is just a PDF document here on the right. And when you make changes, you can also set it to periodically do this. You would want to then recompile it. And it can start to take a little while, but we're talking on the orders of seconds. If your build is ever taking minutes, something has gone horribly wrong and it's a bug, and you should refresh and start over with the build process. But because it is a build process, a little bit of your mind space is going to change between just writing words and potentially, and hopefully this is an uncommon periodic thing, potentially doing actual debugging work. If, for instance, I have removed that closing brace of that begin document tag there, well, first off, the editor is giving me a hint, like a good code editor would, that something is wrong here. And we could probably read it. Invalid environment command, unclosed open group. It's finding some problems. It's giving you a hint as to what's wrong, but just like a lot of language and compilers, they don't exactly tell you, but they give you a hint what's going on. You will find yourself occasionally in a scenario in which you hit recompile. I just wrote 5 new pages. It's amazing. I added 3 new figures. I'm looking great. Yet, instead of a PDF, you have error messages that you then have to debug. For those of you in this class, as part of this process, my advice is, okay, you get an error. Like any other error, you probably want to fix just the first one, because sometimes other errors are actually not errors and it's just confused after the first error. My suggestion is, as we work on these things, spend 3 to 5 minutes trying to fix the error. And if you can't fix the error after 3 to 5 minutes, again, your goal is not to be LaTeX experts. You can reach out to me. I know enough that I can fix your error in 30 seconds. And the way we'll be sharing these files, I'll be able to quickly access it. Just ping me and say, I spent a few minutes. I'm really frustrated because I have all this great content and I can't see it because I can't get it to work. And there hasn't been a LaTeX error I haven't been able to fix in very short order. And again, if you want to learn, that's fine. But like learning any new language, you have to decide how much time you want to dedicate to that versus dedicate to the actual tasks that you're working on for your project. So this is the most basic kind of example that we have here. That's sort of our minimal document. You have these backslash commands here, and every document that's going to start with that document class command here, with the percent sign working as our comments, for which the rest of the line then gets ignored. So everything just goes between your begin document and end document. One thing that is a little bit of a mental context shift as we go between, let's say, the Microsoft Word view of how we edit a document and the LaTeX view is white space. There's certain rules that get followed with regards to white space. Again, this is not intended to be a what you see is what you get editor. Adding those spaces do in fact do nothing for the actual output of our PDF. And I don't know if you can see what I just did there. I just added a whole bunch of spaces, and it actually made, you may say, is that a little difference? It made zero difference in the end result. We will get to the point where it may be important that for whatever reason we want to have, we want to have exactly 4 spaces between the word hello and the word world here. I don't actually remember what's the command for 4 spaces. I think it's something like quad. It looks like it auto-completed it to quad, but I think it's just quad. Give me 4 spaces, and then there's your 4 spaces there. That is the LaTeX view of the world. That may take a little getting used to, but for the most part, we're writing paragraphs, right? Or bullet points and lists, enumerated lists, and things like that. So we're not usually doing, we're not writing poetry for the most part. It probably wouldn't be the right software to write really creative looking poetry in it. Words are separated by 1 or more spaces, and paragraphs are separated by 1 or more blank lines. Now, this is not a lot going on in this document, so it's not really going to look like much, but hello again. That is actually a separate paragraph here. It's not going to look like much because there isn't a lot going on in this paragraph, but that is basically not a line break. That's our paragraph break here. And all those spaces then are also irrelevant. It's going to look exactly the same once I make that change. That takes I would say that takes a little while to get used to, but the rest of that gets collapsed. You can really just focus on the content itself. A couple other things that, again, I can go in and kind of fix them in your document if it's not looking the way you want. For historical reasons, and this is also something that Microsoft Word doesn't do very well either, the way they handle quotes is via special little characters to encode particular quotes. If I want to do the word quotes, something in quotes, so if I want to do hello world in quotes, you can actually try to use the actual, keyboard double quote character. And I understand certainly as you copy and paste from something else, or just how you just naturally type, that is kind of the default way one would do it. If I zoom in on that PDF, I would argue that that doesn't actually look correct because they're both, I don't know, closing quotes, whatever you want to call those. So in LaTeX, the way we in fact do that is we actually use 2 back ticks followed by 2 front ticks to get the correct looking. And I'll show them just side by side so you can see what I'm referring to here. And that one I would say is what actually looks correct. Again, Microsoft Word also screws that up sometimes as well. It'll try to auto format your quotes, and depending on why you're using quotes, you may or may not want those quotes to be auto formatted. You can turn that off. This is a historical LaTeX-ism that it'll feel like second nature eventually. And if you get it wrong, it's fine. I can go in and change it, or we don't change it. But that's just one of those things that's a little unique with regards to it. Because it is a markup language, there are also some characters that already have some special meaning. And so if you actually need them, you need to escape those characters by proceeding with a backslash. Not so dissimilar from what you have to do in a lot of other programming languages. You will potentially encounter some of these things. Percent, hash, ampersand, and dollar all have specific meanings already. So if we're not careful, let's say I just made $500, and it actually tried to fix it for me, but it wouldn't. That is actually going to be a compiler error. Although, if you may have noticed, I had to manually make that error. It tried to fix it for me already. That is going to be a compiler error because the dollar sign is going to correspond to math mode specifically. But if I actually do need the dollar sign, I put a backslash in front of it. It's going to actually give me that dollar sign. Same for other things. That is a raise of 5% for me. That one, maybe visually you can see what's happening here, right? Percent is the comment symbol. So if I actually want a percent, you can visually see already that, yeah, that doesn't look right. I use the backslash, I'm actually going to get my 5% there. That's also the ampersand is the other one as well. But once you have that in place, it's going to look pretty good. If you get that error, we can fix it really quickly. But that's just one of those caveats you have to keep in mind. You will likely use percentages in your report. Made this 5% faster, or use 10% more data. Maybe you'll have dollar signs depending on the context of your work here, and other things, other special characters may be used as well. I already mentioned this, but because it is effectively a compilation process, it'll get confused when it's trying to compile it, and it's usually going to stop. As soon as it finds an error, it's usually not going to keep going, depending on the nature of the error. When they happen, just fix them as soon as they arise. And frankly, when I'm really editing a document and I know I'm going to be working on it for a few hours, I'll periodically just recompile it as I'm going to make sure that I didn't add an error along the way. It's going to happen. Just typos happen. We misspell things. Things maybe get auto-corrected going from one piece of software to the other. Just start with the very first, the top error. Usually it's trying to tell you, like any compiler, what the error is, but I understand that it takes a little bit of experience before you can read that error and know exactly what they mean. Again, 3 to 5 minutes on it, and if you're still stuck, feel free to reach out. I'm happy to jump in real quickly and fix whatever your particular error is. So I wanted to give this one a try, but let's just do it together. If you want to try it, you can. But the idea was to typeset this particular text in LaTeX to see if we can fix the corresponding problems with it. So that's a slightly different link. That's ISU LaTeX 1. I also have it open here as basic exercise. And the idea was to typeset basically that particular paragraph here. Now, you may say, well, I'll never type it up like this because I know some of these issues now already with regards to LaTeX. It's very common to take a phrase that you want to include, and you're going to maybe copy paste, or other people still use Microsoft Word and Google Documents because they're just really comfortable editing in that mode, and they write down their ideas and then they want to import it into LaTeX. When you do that is when you're going to get a block of text that looks like this, that does, content-wise, does what you want, but it's no longer encoded exactly in the right way. We'll go around the room. Let's fix each problem as they come. So starting with in March 2006, what's the first error we have here? The dollar sign. How do we fix it? Backslash. There's 2 of them, which is approximately, okay, what's the next error? This is too easy. What's the next error? Right. And I would call that it just doesn't look good versus being an error. Like the compiler won't complain about that, but I don't like it. It's not the right kind of quotes. And dollar. Now, again, if we go back and we didn't fix this one, again, the editor is trying to tell us that whether or not we see it at the time or whether or not we get it, you also then want to gain a little bit of experience in terms of reading this. When you hit compile, certainly when your report's almost done, I'm going to ask you, hey, are there any errors? Or certainly certain warnings are actually also errors, just like with any program that we're working on, right? And you're going to want to have those all fixed. So here, it does look like it's telling you that it tried to fix it itself. Let's see. It didn't. It failed at trying to fix it itself, unfortunately, right? But it said missing dollar sign inserted. And it's even trying to give you some hints that like, hey, use that for math mode. But we're not doing math mode here. We're trying to actually use the dollar sign. And it claims on line 18 it added a dollar sign, but that fixes the error. That would technically fix the error, but that's not what we actually wanted. So it found an error. It tried to fix it, but the end result wasn't what we wanted. The end result looked like kind of like one big long equation, sort of. It was trying to treat it as one long equation. That's not what we actually wanted. So even though it generated a PDF, we see that little red number 1 pop up there. We do want to fix it at that point. Well, congratulations. Your first LaTeX document has successfully been built here. So why are they special? That corresponds to math mode. And you will probably be using this in your document. I mean, different reports have more or less math. We are not mathematicians. We can dive into some of the math if we want to. It really depends on what we're trying to show. Um, some people like to write, a paragraph about a concept. Others like to just represent it as an equation. One is not really better than the other. It really depends on, maybe your field, what is expected in that field, or just what you feel more comfortable expressing yourself. Whether you can express yourself via sort of formal mathematics, or whether you just want to explain in English what you were trying to do. You'll probably have some amount of math mode in your report, and that's what's happening here. That's why I was unhappy about the dollar sign, is because it is meant by default to indicate that something you're referring to is a mathematical expression. That's where LaTeX can get pretty gnarly looking. No more difficult than using, like, let's say, the equation editor in Microsoft Word, but it tends to be the kind of thing that you have to be able to Google to learn exactly how do I encode exactly what I want to encode mathematically. If it's y equals mx plus b, we can probably figure that out, and that looks pretty good here. But as we want to do more potentially advanced math, I think one of these prior slides had an example of what that could look like here in the lower right-hand corner here. This value is based on some definite integral, etc. Um, there's definitely a way to do it. For any mathematical expression you ever want to represent, no matter how simple or how complicated, there's definitely a way to do it. The question is how much time you want to be spending looking that up versus just focus on content. I can certainly help with that as well when the time comes. That's part of the beauty of LaTeX. The algorithms for rendering math are very advanced and have been developed over a period of decades. But if you're just doing y equals mx plus b, it's not really that big of a deal one way or the other. It's just some examples of what we can do in math mode. And again, here's like a polynomial. You use the caret for superscripts. You use the underscore for subscripts. Something looks a little wacky with this document here, but it's fine. Curly braces for when you want to have more than one character in a superscript or subscript. And we can just fix that real quick. It looks like that got moved up a little bit. And then there's commands for Greek letters. Every mathematical symbol you've ever read in a paper has a LaTeX command for it. Sometimes you just have to look it up. Some of them are obvious, others are not obvious. You have in this example, you have lowercase mu. Here you have um, uppercase omega versus lowercase omega. And whether it's simple or not, it is at least completely consistent from left to right. It does exactly what you want it to do from left to right. And it's just a matter of looking up examples or Googling how to exactly get the summation symbol to look exactly the way you want to, or complicated fractions or square roots or anything mathematically you want. Um, I can definitely help. You also may enjoy exploring that and learning through it. You may not have that much math in your report, but that's really part of the strength of this software. It's why people use it a lot here. If it's something that doesn't fit nicely inline, you may want to use an equation environment. That's what this example is showing here, versus having it be inline with the text. It's actually a separate breakoff in the text, which may or may not be a numbered or unnumbered equation. That can look pretty good. I don't know how much time, if it's worth spending that much time for us building it ourselves. We have some examples for how to do that. There's another exercise here. I think it's sufficient to say, write it out by hand. Whatever math you want to represent, you can represent, and that's straightforward. And it will look very nice too, as well. It'll look a little more professional as well. Then there's for the itemize and enumerate environments. That's also a little bit of a learning curve as well, that when you want to now have a bulleted list, you have to use the itemize environment. When you want to have a numbered list, you have the enumerate environment. I think for our purposes, the defaults for either of those environments are going to look just fine. It gets a little hairy once you want to really customize what those bullet lists are going to look like. But for our template that we'll be using, the defaults look perfectly good, and I think you're in pretty good shape if you just use that. So that's bulleted list versus numbered list. It's no longer something you click in the GUI, it's just its own separate set of commands associated with it. And then for all the other things that aren't kind of in built-in vanilla LaTeX, there are then this concept of packages, just like with our Python code. We can do a lot which is built-in Python. When we want to do anything with regarding scientific computing, we need to use those packages. When we want to plot something, we need to use those packages. It's the same kind of concept here with LaTeX. Part of using a template and part of using a starter is usually, and we'll see, you may have some special needs that we can figure out as we get there. Usually you start with that template, it's got everything that you need. Just like you start with a collab workbook for doing some machine learning, and it's got everything you need already. You don't have to really think about what each package is doing. Same thing with LaTeX as well. There are hundreds and hundreds and hundreds of these packages. Um, Usually the answer is, can I do XYZ in LaTeX? The answer is yes, but it requires a special package. Here's what it's called. Here's how you have to use it. We're not doing anything so custom that I think we need too much of that. We're pretty good with just kind of built-in stuff. It's going to look perfectly fine for us. So we'll skip the extra math examples here as well. You can review those slides separately. Again, it winds up looking pretty nice here. I also have an exercise for how to do exactly this example in LaTeX, but I think we'll skip it for reasons of time here. Um, None of the things we're doing so far are that heavily mathy with regards to your reports. I'm also going to skip over this section that talks about how to create the title and how to create the author block and how to create your abstract. The reason I'm going to skip over that, not that it's not a useful thing to learn, is that what we're going to do instead, and same with section and subsection, is we're going to be using the Iowa State template, which does things very slightly differently. And so this is the more generic way to do it, which is nice to learn. We're going to have to do it the Iowa State way, which is just using their template that they have provided. One thing that you will have to learn is this concept of labels and refs. And you don't technically need to do it, but your life will be much happier when you do, is that when you want to refer to something by number or by label, you have to explicitly first set that label in your document using the label command. And you give it some sort of descriptive. It doesn't have to start, this is the first section, that's the introduction. It doesn't have to start with the letters SEC colon. That's just one way of kind of ambiguating your labels here. It's like naming a variable in a way that you can understand the variable later. And then later, you can refer to those sections using the refer or reference command. And that is part of what that compilation process is doing for you. It's resolving all those references. It's determining that introduction happens to be section 1 and the method is section 2. Now you may say, well, why can't I just write the number 2 here? In section 2, we ... And you can. That will work. It's not wrong. The template will give you a nice hyperlinked reference, and so someone can click and go straight to section 2, which would be pretty nice. The other gotcha that will happen sometimes is as you're writing, and this is true for Microsoft Word as well. You can do the same thing with references in Word also, right? Is maybe that was section 2 when you first wrote it, and then you realized a week later, you know what? That should actually become section 4. I've changed my mind. I'm going to cut and paste this whole thing and move it over here. If you hard code it as in section 2, well, now you got to go back and edit your work and make sure that I actually change all those references manually. If instead you actually use these labels and you refer to these individual labels, then that all gets taken care of for you. Your chapters may not change their numbers all that often. Our chapters should look pretty similar: introduction, related work, our approach, experimental setup, results, conclusion. Feel free to tweak that, but pretty much it's all going to look like that roughly. What will change is going to be our bibliographic references. Those will change as you go. And if we want to use like numbered references, in paper 7, the authors discuss this. You do not want to do that manually because that's going to change quite frequently up until the very minute you submit your report. So for that, we will be using a version of this that's called cite command. We won't do this exercise either. But specifically for homework number 2, which is we're building our literature survey tree. We have one nice example tree, and I appreciate that, and it looks great. We're expecting many more before next week. We're also actually writing up that chapter 2. I want you to use LaTeX for this. I'm not trying to be difficult. I'm not trying to give you busy work. I want you to do it correctly now so that you do not have to do it again, because you will eventually have to do it. So what we do in LaTeX is we put our references in what's referred to as a BibTeX format. This is a .bib file, and while it doesn't have to be a separate file, best practice these days is to have it be a totally separate file. And you then upload that file as part of your Overleaf document. So it has one or many .tex files for the LaTeX source, like we have open here, and then we have one or many .bib files for that aspect as well. And they have that kind of funny looking format in which it's sort of a citation key. Um, it has the author and the title and the journal and all those things, and you're supposed to have all those information. You can make the key whatever you want, but it's usually good practice to make it something that will make sense to you a few weeks from now. This is a Google style auto generated citation key. And I say that because when I actually go to Google Scholar, and we can look at anything in Google Scholar, I'm just picking a totally random one here. I actually want to see the entry though. I want the Google Scholar entry here. Um, it's not this is just the abstract that it's showing here. So let's look at, I don't know, high level synthesis. That was a random one. That's a book. Here's a random paper. The best way for you to generate these is to then click that cite button. The style is kind of irrelevant. That's if you were using Microsoft Word or EndNote and we're directly doing it. You're then going to want to click the BibTeX entry for every one of the papers you found. And it'll give you just that raw text file. Control A, Control C, copy paste that into your .bib file. And it's okay. Include as many things as you find as you like. You don't have to cite them all. You don't have to include them all. You may have downloaded a paper and looked at a paper, and then 2 weeks later you realize this isn't relevant at all. I shouldn't include it. The nice thing about using BibTeX and this kind of management of our citations is if you don't refer to it in the paper, it doesn't get included in the PDF. So even though I want to see 30 references at the end of your report, you may have 100 papers in your .bib file. Only the ones you actually cite inside your paper will get included. So you're not adding garbage to your document. It's not invalid in that sense. You would copy paste that, put that in a .bib file, add that bib file to your overleaf document just by uploading a new file in the actual menu that you have here, and then you can start to cite those references in your document itself. There's a few different packages for doing that. We're going to use the iostate template for that. So we're going to skip that exercise. Where I'll actually want people to go, and again, I want to make sure the people who created this get credit. This is the Iowa State Library. Eric put these slides together. They're very useful. Is to go to the Iowa State page for Overleaf. And this link is on this document. It's the very last link on that slide 31 there. I kind of want people to do that today. If you do it tonight, that's fine, or tomorrow, that's fine. Please do it though. And when they watch this video, I want you to do it. This is actually, I think the link is the Overleaf overview. This is overleaf.com/edu/iastate. And it's got some guides, some quick starts. That's all very nice and well. What I need everyone to do is to go to the templates, of which there's several different examples, but the one you want to do is ISU template with traditional format. And I want you to do a few things here. Of course, I want you to click that. And then you're going to click Open as Template. And it will create for you a new project. Generally, you're going to want to edit the name of it because everyone's going to look exactly the same. You'll notice I have 6 other copies of this, so I've clicked that link a few times before myself. You're going to want to call it, Zambrino Creative Component Report or something like that. Okay? Just to make sure that when I get access to it, I can tell who is who. And then I'm going to want you to share it with me personally. This link will not work for me because I'm logged in as myself. But this is an assignment. I actually want you to do this. Go to that, rename it your NetID or whatever. Steve's Creative Component, that's fine too. Something I can look at and know what I'm talking about, and then I'm going to want you to share it with me. And well, I can't share it. I'm the owner of this one, but you're going to want to share it with my email address. Not going to be that's not going to look because it's myself, but I'm not going to be looking over your shoulder. I'm not going to be judging the words and the temporary text that you have. I'm there because I need to review these documents. I need to sign off on these documents. I need to help if you're stuck on something and actually getting it to work for you. But this template, while it's got a lot of stuff going on, you'll notice it's not as simple as the other example where there was just one file on the left and one PDF on the right. Now there are a number of files included here, including multiple style files and the like. It's still a really great place to get started because you don't have to touch most of this stuff. In general, although it doesn't work with all features of it, in Overleaf, you can double click where you are in the PDF and it'll route you to roughly where you are in the LaTeX files themselves. So, hey, this title's no good. My title can't be called "This is the title of the thesis." You don't, by your assignment's not to change it yet, but saying, okay, this is included via preface, title page. Preface is a folder. Title page is yet another text document. I don't know if I click it again if it'll find me that. No, it just is going there, but it's inside this document. If I now want to change it to something a little bit better, my tremendous report, and you put your name in there. I don't care that much about the title page yet. You may feel happier looking at something that's the correct title page, versus like some arbitrary template tile page. This is meant to be the starting place for you. It includes, for example, an example bib file, which you can delete all these entries that are not relevant for you. You can just add your own references to that. And it's got everything you really need to get started with working on your actual report, including it already lays out some generic chapters for you. And I'm going to want you to do your chapter 2 for this homework number 2, which is your related work chapter. Generates all the table of contents for you. It does all those things for you. That is now your task. As you're finding your references, as you're organizing them, as you're putting them in a .bib file, as you're downloading those citation entries from Google Scholar, as you're finding these things and reading them, I want you to actually write this section. That is homework number 2, to write that kind of annotated bibliography and then the actual review of the literature that you've been reading. I want it in this document that is then shared with me, so you don't have to worry about uploading a separate file in our OneDrive shared storage that we have here. Any questions about where we're at with regards to this? Let me try to double check it. So Iowa State. Does it show if you use Iowa State? Because when that link looks okay. I'm not saying you're wrong. Let me click it and see where it takes me. Doesn't mean you're wrong. Doesn't mean I'm right. It's the right URL for whatever that's worth. Maybe you have to be logged in first. I wonder if you have to be logged in first, because that looks like Iowa State's website, though. Yeah. Okay. Well, let me stop the recording here, and then we can debug that so everyone can get to that page. But that link should work. Okay.